Good morning. This is lecture video continues of lecture series 1. Today we see about properties of the polymer. So first of all, what is meaning of polymer? A polymer is any classic class of natural or synthetic substance composed of the very large molecules called macromolecules, which are multiples of simpler chemical units called monomer. Polymers make up many of the material in living organisms and are the basics of the many minerals and man-made materials. Some of useful properties of the various engineering polymers are high strength or modules or to weight ratio, lightweight but is a comparatively stiff and strong, toughness, reliance, resistance to corrections, lack of conductivity, heat and electrical, color, transparency, processing, and low cost. So this diagram is a graph diagram. It shows relation of stress strain diagram and material behavior. The first we shows the diagram. We draw about x-axis we take as a strain and y-axis we take as a stress. So whenever we increasing the strain and stress, the curve will be increasing 1 and 2. When further we have to increasing the strain value, the graph will be get elongated in 1, 2 to 3. The further we increasing the stress and strain value, the certain time the fracture will be happen. The region, there are different types of region. Those are called elastic region, plastic region, and strain hardening and the fractures. The second graph shows the different materials, that is the ductile and the brittle. Based on the characteristics of the load, the graph will be shows. Whenever the increase in the stress and strain, we increase in the curve will be increasing gradually, and certain time, the certain period, the graph will get reduced in the certain applied stress and strain. What about brittle material? Is initially it have a high, but in certain point the brittle material get break having of stress and strain values. So what is the mathematical problems of stress and strains? So what is meaning of stress and what is meaning of strain? The stress is nothing but load by area or force by area. What about strain is called as change in length by original length. The we are indicating as a symbol of sigma is equal to F by A, which is called as stress formula. The sigma is called as stress and F is called as load or force. A is called as area of the object. So what is the units of the sigma? That is called as stress, Newton per meter square. What about S? What is the unit of force? Is called as Newton, and the area we denote as a meter square. So similar, we have to derive the strain formula. Strain is called as change in length by original length. The strain having no units, the length, the change in length we have to indicate as a meter, and the original length also we have to indicate a meter. So meter get cancelled. So we getting a sigma. It has a no units. So what about Young's modulus? Young's modulus is nothing but relationship between stress and strain. That's nothing but E is equal to sigma by E. The same SI unit for Young's modulus, it having a Newton per meter square. So what is meaning of change in length? That is a final length minus initial length or original length. So these are the basic fundamentals of the stress and strain. We see some problems about the stress and strain. First numerical problem. A hollow cylindrical 2 meter long has an outside diameter of 50 mm and the inside diameter is 30 mm. If the cylindrical is carrying a load of 25 kilonewton, find the stress in a cylinder and also find deformation of the cylinder if the modulus of elasticity is 200 gigapascal. So first of all, we have to convert into same SI unit. When problem is given in a hollow cylinder, the hollow cylinder means it having a two diameter. One is outside diameter, another one is inside diameter. So the outside diameter's value is 50 mm. So 50 mm we convert into meter or 2 meters of long cylindrical we convert into millimeter. So we are converting into one form of the units. What about inside diameter is 30 mm. So 200 gigapascal is a E value, that is Young's modulus. So gigapascal is means called as 10 to the power of 9 Newton per Newton per meter square. So we convert into gigapascal into Newton per square. So we convert into 200 into 10 to the power 3. So what is the main objective of this problem? To find the stress and deformation of the cylinder. What about formula of stress is called it as load by area. So here area is a hollow type. So we have to need to find out the area of the hollow of cylinder. So what is the formula to find the area of the hollow cylinder is pi by 4 outer diameter minus inner diameter. Here the outer diameter is indicated as a capital D and the inner diameter is indicated as a smaller d. So we square and subtract and multiply with pi by 4, we getting area value. So we already given the load value. The load value is given into 25 kilonewton. So we convert into Newton. So substituting with those values, we getting sigma. The sigma value is 19.9 Newton per square. So deformation of the cylinder by using of both strain formula and Young's modulus. So combination of strain and stress and Young's modulus, we getting there is this formula. The change in length, that is called as deformation of the cylinder, is equal to load into length by area into E. So we substituting all the values, we getting the deformation of the cylinder, that value is 0.4 millimeter. Thank you.